Hello everyone, let's take a look at the review for section 7.1, 7.2. In this section, we talk about multivariable functions. So multivariable functions are functions of more than one input variable. For example, I have the function f of x comma y. This is the function of two input variables, x and y. I can also have a functions p of s comma r comma t. This is the function of three input variables s, r, and t. In working with multivariable functions, we're going to use tables, formulas, we're going to look at contour diagrams, and cross-sections graphs. You can also look at some of the problems in the problem set to do with tables and formulas. Here, I'm going to go over contour diagrams quickly. A contour diagram tells us about the surface of the function f of xy. On the contour map, all points xy on the same contour have the same function value f of xy equal to a constant c. And when you read a contour diagram, the general rule of thumb is that when the contours are close together, the surface is steep. And when the contours are far apart, the surface is flat. Next, we talk about change and percent change. If we have change in f from x1, y1 to x2, y2, the formula for change is f of x2, y2 minus f of x1, y1. This is the function of two variables x, y. So that's why you have f of x2, y2 minus f of x1, y1. You can think of this change as the new value minus the old value. For the percent change, I have the formula f of x2, y2 minus f of x1, y1 over f of x1, y1, or new value minus old value divided by the old value. For the rate of change, it is related to increasing, decreasing, and the steepness of the function. For the multivariable functions, you must specify in which direction you're talking about. You can use the phrase with respect to WRT to indicate the directions that you're talking about. That's section 7.1. For section 7.2, we talk about cross-sections of a function f of xy. So this is the function of two variables. The cross-section is that of the single variable function obtained by plugging in a specific value for either x or y. For example, consider the function f of xy equal to cosine of pi x plus y. And I want to find the cross-section f of x comma 1. This is the cross-section when y equal to 1. That is cosine of pi x plus 1. Similarly, I can find the cross-section when x is equal to 0. When x equal to 0, I have f of 0 comma y equal to cosine of 0 plus y, and cosine of 0 is equal to 1. Therefore, the cross-section when x equal to 0 is 1 plus y. We can also find the derivative of cross-sections. For example, consider the function f of xy equal to 50x times e to the y plus 5x squared plus y, and I ask you to find the derivative of the cross-sections f of 2 comma y. So to do this problem, the first thing you need to do is you need to find the form of the cross-sections f of 2 comma y. That is 50 times 2 times e to the y plus 5 times 2 squared plus y. Now if you simplify the right hand side expression a little bit, you have 100 times e to the y plus 20 plus y. Next, you can find the derivative of this cross section. That is the derivative of 100 e to the y plus 20 plus y. The derivative of the first term is 100 e to the y. The derivative of the second term is 0 because 20 is the constant. And the derivative of y with respect to y is 1. So therefore, the derivative of the cross-section f of 2 comma y equal to 100 e to the y plus 1. This is the end of section 7.1, 7.2 review. Please let me know if you have any questions.